everybody, today we're going to talk about solid figures. So let's go ahead and figure out what are those anyway. A three-dimensional figure is called a solid. We're into 3D shapes now. When a solid is formed only by polygons, it is called a prism. And prisms and pyramids are examples of polyhedra. So a three-dimensional figure is a solid, any three-dimensional figure. When a solid's formed only by polygons, remember what a polygon is too, no curves, right? It's called a prism. Prisms and pyramids are examples of polyhedra. To name a prism or a pyramid, we name it by the shape. This should be let's put that in there, by the shape of its base. Okay, so let's look at this prism down here, this example. So the base is what it's sitting on, and I tend to call a top base and a bottom base. So I'm going to use this little highlighter here so you can see. There's a top base here, and there's a bottom base right there. And those are planes. So when we name those, we have to name them like a plane. So let's talk about the top base. Remember, when you name a plane, you only use 3 points in that plane. So if I'm talking about that plane right there, I can call it plane HGF, or FGH, or FEH, or HEF, or HGF. You know, I could just go on and on, right? But just use 3 of the letters. So the top, I'll just call it HGF, all right? There's also a bottom base here too. On this bottom base over here, we also have 4 letters. Just remember, whatever you name it with only 3. So you can say ABC or BCD or DAC or DBC, you know, like you can go on and on. So I'm just going to call it straight up plain ABC. Okay, so top base, bottom base. What's cool about this figure is I could knock it over and then the base would actually be one of the sides. So, you know, I always go by what it's sitting on, but you could technically knock it over and use a different dimension here, a different piece of this as the base. All right, let's talk about faces. So faces are your sides and also your bases. So sides and bases are your faces here. It's basically every surface. Every surface. Okay, so let's look over at this shape and let's see how many of these we have. So we've got 1, 2, 3, and then the back here, 4, 5, and then you probably can't see it, but we've got 6 right here in the front. So there are 6 faces in this picture. Okay, so let's look at the next one, edge. Edge, I say it's a line segment, and it's a line segment that connects 2 points. Or, if you want to sound real fancy, connects 2 vertices. Okay, so let's look for the edges here. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. I count 12. And I have to tell you, some students resist outlining the shape whenever they're doing their working class on this section, and you really should outline it because it's hard to keep track of what edge you've like picked already unless you outline it. So I highly recommend outlining your solid. All right, the last one, vertices. This would be each point, each intersection. I'll say each intersection. Each intersection of edges. Now, okay, so each intersection of an edge, wouldn't that be here and 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 here? So you'll see those are the points right there, right? How many are there? 8. 8 of them. And I'm writing these down, by the way, because we're about to use this information in just a moment. So hopefully you understand the vocabulary now. What a vertice is, what an edge, I shouldn't say vertice, what a vertex is, vertices are plural, edge, face, base. Next thing we're going to talk about is Euler's formula. So the number of faces, vertices, and edges are all related. They will always satisfy this equation right there. Let's use the prism above and show what happens. So we're going to use this exact equation right here. So we have F plus B equals E plus 2. This should work with the prism that we have right here. So first, how many faces does this prism have? Go to the word face, look over, and I see 6. Plus, how many vertices does this have? Go to vertices, I see 8. Equals, how many edges does it have? Go to edge, I see 12. So 12 plus 2. So 6 plus 8 is 14, and 12 plus 2 is 14. So yay, the equation works. All right, let's use it down here. If a shape has 12 vertices, that's your V, and it has 30 edges, that's your E, how many faces does it have? So as soon as they ask you this type of problem, you want to go straight to Euler's formula. Now, you don't have to. Do you want to draw this? Because I sure don't. Trying to even think about drawing it without knowing how many faces it has too would be really difficult. So this formula is used because it would be really difficult to draw the picture. So that's what makes this easier. So for F we don't know, V we know is 12, and E we know is 30. So then on the right hand side, if we do 30 plus 2, we'll get 32. And then if we subtract 12, we'll get 20. So this solid has 20 faces. Would you have known that without the formula? Probably not. Okay, so now that we have that done, let's keep on going. I'm going to move it down. Let's talk about what are not polyhedra. So solids with curved surfaces are not polyhedra. So the cylinder, notice the curve, the cone, notice the curve, the sphere, notice the curve. They're not polyhedra. Now they are solids. They are solids, but they're not polyhedra, okay? So down here, tell whether each solid is a polyhedron. If so, identify the shape of the base and then name the solid. Please read these directions. There's 3 things going on here. Is it a polyhedron? What's the shape of the base? Name the solid. Now, polyhedron are named by their base, which we talked about at the beginning of these notes. So I'm going to actually skip number 1 because I'm going to have you do that later. But before you even try number 1, let's talk about number 2. On number 2, I don't see any curves whatsoever. So yes, this is a polyhedron. The next thing you want to look for are the bases. Now remember, the bases are parallel to each other. This is parallel to this. There's no other 2 bases that are parallel to each other in this picture. So those triangles must be the base. So the triangle is the base. Now, since a prism and a pyramid are named by their base, and the base here is a triangle will be in your name. You have to ask yourself, is this a pyramid or a prism? Well, a prism has 2 bases. A prism has 2 bases, and I want you to jot that down. Prism has 2 bases. Okay, a pyramid has 1. So looking at this picture, I have 2 bases here. So this is a triangular prism. Triangular prism. Now this guy over here, number 3, I see that there are 2 parallel bases here. No curve. So yes, it's a polyhedron. And I would probably say that the square is its base. You can say a rectangle if you want, but I think it's a square. Then I will call this a cube. Okay? You can call it a rectangular prism if you want, since we don't really know if it's square or not, but I'm going to call it a cube. I want you to do number 1, please. Bring that to class next time I see ya. Now let's go on to 4, 5, and 6. So on 4, do you notice that there's only 1 base? So if there's 1 base, it's a pyramid. So 1 base is a pyramid. So looking at number 4, I see 1 base. So yes, it's still a polyhedron. And what's the shape of that base? Well, I don't know if it's a square or not. I'm just going to say it's a rectangle. I think it's a square though, but I'll say it's a rectangle. Because when it comes to these pyramids, if there's a shape like a rectangle down there, you're going to go with that. So rectangular pyramid. Rectangular pyramid. I'm going to have you do 5 on your own for class, but let me talk about 6. So first thing, there's no curve, so yes, it's a polyhedron. And the next thing you need to look at is what's this shape here? It has 5 sides. What shape has 5 sides like that? A pentagon. So the pentagon is the base. Now remember, it's going to be named by its base. And notice that there's only one base, so it must be a pyramid. So it's a pentagonal pyramid. I'm sure I mispronounced that, but I think I spelled it right, so that should earn me some points. All right, so you do number 5 for class. And 7, 8, and 9, let's talk about those. Are those polyhedron? Does it have curves? It does, so no, it's not a polyhedron. Does it have curves? It does, so no, it's not a polyhedron. Does it have curves? It does, so no, it's not a polyhedron. And if you're real observant, didn't we just see these 3 shapes? Right there. Cylinder, cone, sphere. They're not polyhedra. All right, so those are a big no. Now, I want to end this video with something a little bit creepy I found on the internet. So here we go. Enjoy this little ditty right here.